Hello guys, my name is Engineer Holiday. We want to discuss introduction to electrostatics. Introduction to electrostatics. But before we talk about electrostatics, there are so many things that are surrounding this topic. Now, now when we talk about electrostatics, we are talking about what? The study electrostatics. Statics is the study of discrete charge or continuous charge at rest. At rest. So in this case, and what we are saying now is that if we check if I split this word into two now from here, electro from the word electron, which is charge, there is statics from the word rest. So if you now combine the study of electron or study of charge at rest is what we call what? Electrostatics. So when we talk about electrostatics, we are talking about the study of what? Discrete charge. When we talk about discrete, we are talking about separate and distinct charge at rest. Now, I've mentioned charges, but there are so many things that surround charges. In fact, the presence of charge can create an electric field. The presence of charge or even the movement of charge can also make what? Us have what we call a magnetic field. Now, it will interest you that I would like to talk about, to give a brief what? Explanation about what we call electromagnetism, because there are so many. We have talked about electrostatics. I want to talk about electromagnetism. If I see split something like this, I'm having two parts of it: the electro and magnetism. Magnetism is a physical attribute. Magnetism is what? The physical what? Attributes. Attributes through what? A magnetic field. Magnetic what? Field that what? Allow what? Object to attract or what? Or repel what? Each other. So that is magnetism for you. Then that means that we have mentioned what they call magnetic field inside. Then electron, what? The presence of what? Of charge creates what? Electric field. The presence of charge creates what? An electric field. The presence of charge or electron creates a magnetic field. So therefore, what is now electromagnetism? So electromagnetism is the interaction. It is study of what? Let me put it. It is study of interaction of magnetic, or let me start with electric and what? Electric field and magnetic field. So if you split it like this, now we now have, that is to say, magnetism is that physical attribute through a magnetic field that allow a magnet to what, or an object to attract, probably if they are what, unlike what, magnet, and repel if they are what, like magnet. So now that magnetic field is what we talk about, that brought about what? Electromagnetic field. That means electric field and magnetic field together comes together to produce what they call a term called electromagnetic field, which is the study of interaction of between what? Interaction between electric and what? Magnetic field. So that is to say magnetism is created, is a term that is formed as a result of the study of interaction of electric and magnetic field. Electric field is a region of space where an electric force is being what? Experienced. Magnetic field is what? Is a region or area on what? Where what? There is an impact of magnetic force on the what? On a magnet. That means a region of space where magnetic force is being impacted or is being detected. That's what we call a magnetic field. So that means that there is no magnetic field without the presence of magnet. There is no magnetic field without the presence of magnet. There is no magnetic field without the presence of elemental particles. All this we are going to discuss in the what? In the future when we are talking about magnetic field. As you follow me, please, if you are a returning viewers, please just subscribe so you can always I mean, you are returning viewers, thank you for watching. Then those of us that are new subscriber or you are just seeing me for the first time, thank you very much. God bless you. Now let's continue. Now we have talked about what? Electrostatics, as in what? The study of discrete or continuous charge at rest. We have also talked about magnetism as the what? As a physical attribute that what? Passive or that is through a magnetic field that allow or that create that what? Environment where object can allow to what? Repair or attract each other. So in that case, that means magnetism can also be likened to the ability of a magnet to attract or repel each other. So that is when I say that we cannot have a term called electromagnetism without two terms that are brought in. Two one is brought in through electro, which is charge, electron, and one is brought in through magnetism, which is magnetic field. So when we now talk about electromagnetic field, we are talking about the interaction, the study of interaction of what? Magnetic and electric field. Now we have also mentioned things here. We have mentioned charge. Charge. What is a charge? So charge or charges are intrinsic property of some particles. We can also say that what? Charges are what? Are intrinsic what? Property of which what? Matter are what? Are made. So charges are what? Are intrinsic. When we talk about intrinsic property, we have extrinsic property. Extrinsic are what? Extrinsic property are what? From the outer part. That means the external influence would create the property. That means decide the property of such a particular material or that system. While intrinsic property is what? Is determined internally. So a charge property is what? The charges properties are determined internally. And that's why charges are very, very what? Wide in terms of studying them in physics. So because we know that charges actually what? Is what? The product of current and what? And time. We know that. Also, we can know that, don't forget that the rate at which charges are flowing in a particular circuit is what we call what? Current. Though we are not discussing that now. And also, charges can what? Can exist in two ways. Can be either positive or negative. I'm coming there. Now, if you have a structure, let me talk about what? This. Charges are what? Are two types. We have positive and we have what? Negative. Now, we can have a positive charge and we can have a negative charge. A positive charge is as a result of what? Loss of electron, while a negative charge is as a result of gain of electron. So when a particle or one and what? An atom gains an electron, it becomes what? Negatively charged. So why when it's what? Positively charged, because he has lost one electron. And don't forget that during the period of losing an electron, the body becomes, or the particles become, or the object becomes ionized. And that brought about what they call ionization energy. And what is an ionization energy? Because ionization is as a result of loss or gain of electron. But what is now the energy, the ionization energy? Ionization energy is the minimum energy or the least energy required for an electron to be removed in an atom. Ionization energy is the least or minimum energy required for an electron to be removed from what? An atom. Now, let's continue. I told us that what? We have what? This one is deficient of electron and this one is efficient of electron. If deficient, positive charge is deficient because it's losing electron to become. For example, if I have a sodium, for instance, and I what? Remove one electron from sodium, it becomes what? Sodium plus. Becomes sodium plus. Or they will say sodium is equal to sodium is achieved by what? Addition of what? Of electron to a what? A sodium plus. So that means that if you remove one electron from sodium, it becomes ionized sodium. And this ionized sodium creates an electric field around them because there is a presence of charge in that particular sodium. Now, let us move further. Now, if you want to talk about the structure of atom can be described using what? These three word particles. The structure of an atom. The structure of an atom can be described by using these three word particles. The structure of an atom can be what? Described with the following what? Particles. Number one is what? The electron. Number two is what? The what? The proton. And number three is what? The neutron. So that means that you cannot describe this what? And what structure of an atom without what talking about all this. So if I want to discuss what the structure of an atom, I must know the particles. These are the particles. Then after the particles, I must consider the charge. These are the charges. I must know the mass of the body or the mass of the particle. Then lastly, I must also know the charges they carry. The charges they carry. That means this one, let's call this one the sign. The positive sign or negative sign. Now, if I want to do that now, I can say now this particular one is what? Minus E. This one has what? Zero charge sign. Then this plus E. So that means the sign is talking about what? Then this one is mass is about what? 9.1 times 10 raised to power minus 31 kg, although these are constant parameter which will be given. The mass of proton is 1.6724 times what? 10 raised to power minus 27. This is kg. Then mass of what? Neutron is 1.6727, something like that, times 10 per what? So that means that what? That the mass of neutron is greater than mass of proton slightly, and mass of proton is greater than mass of what? Electron. Please take note of that. Then this one, what? Mass of what? of proton and neutron are very close. Then this one now, don't forget that this charge here is minus 1.6 times 10 power minus 19. Actually, that is the actual value. Then this one is what? Plus 1.6 times 10 power minus 19 column. So this one does not have what? Neutral. It is neutral. So it does not carry any charge. So it's what we can say that neutron is a chargeless particle with mass of 1.6727 times 10 power what? Approximately minus 27. So this is what there are more values to be given, but I just give you something that is in a 4 decimal place. Or let me say, yes, it's 4 decimal place. So now let's go. Let's move ahead. So please, we have some other massless and chargeless particles that they are not part of the structure, they are not used to describe an atom. Now, the problem some students have is that they will always ask, where can we find the proton in an atom? If I draw a structure of an atom like this, let's say this is an atom. This is an atom, for instance. Draw this structure of an atom, for instance, follow me. And I gave you what? The nucleus. The nucleus is what? Containing proton. 2 proton and 2 neutron. For instance, let's say helium, for instance. Now, this helium in question have what? 2 proton and 2 neutron. How do you calculate neutron? Don't forget, neutron is what? Calculated as what? Mass number minus proton number, which will give us 2. So now, there are 2 proton and 2 neutron in the nucleus. This is the nucleus of what? Which is called the central core. The central what? Core of an atom. Of an atom. Then it will be surrounded by what? Electron. Although Rutherford told us that what? That the what? Nucleus is where the proton is found and is surrounded by the electron. But he could not also explain neutron. It was James Chadwick that discovered neutron. Now let's continue. We're not going there. Now let's look at it critically. That means that what we are saying now is that the 99.9% of the mass of an atom is what? Concentrated as the what? The nucleus. That is point number 1 we need to know. Why did I say so? This electron, this electron. 99.9% of what? Of the mass of an atom is concentrated at the nucleus of an atom. Now there's something you must know. Now the mass of, look at the mass of electron now. Then look at the mass of proton and neutron. Then you should be able to, something should be sent to your memory that something is happening here. If you check the mass of what? Mass of neutron, you can work with your calculator, and mass of what? Mass of proton are roughly or approximately what? 2,000 times the mass of what? Of electron. You can do that one with your calculator as you are watching me now. Now, when we say roughly, we mean approximately the mass of proton and the mass of neutron is approximately equal to the mass of what? That means approximately equal to 2,000 times the mass of what? Of electron. Now, that is to say, multiply the mass of proton, the mass of electron by 2,000 and see what you are going to have there. You see you are going to be having 1.8 thereabout times 10 raised to the power minus 27, which is, when you say approximately, that difference of about 0.2 thereabout, which is approximately the same. Now, what we are now saying is this, that since the mass of proton and the neutron are roughly 2,000, that means that don't forget that the neutron and the proton are found in the nucleus, or the central or the dense core of an atom. Now, it then means that the mass of this atom is decided by this nucleus, of the mass in the nucleus of an atom. Another thing again you must know. Now, don't forget that there's a proton here, there's a proton here. There's what we call electrostatic force that exists between proton and proton. And we call that electrostatic force of repulsion. Why do we call it repulsion? We know that when you have two charges, they will repel. Why are they repelling? According to Coulomb's law, we are going to get there. He said like charge repel while unlike charge attract. So when you are now talking about two proton is positively charged, neutron is neutral, while electron is what? Is negatively charged. Now, when we are now saying that the charge that exists between proton and proton is what? Is electrostatic force of repulsion. Why? Because they are like charges. But there is what is holding this electron together is still this one of the, like for example, this proton is positive, this one is negative. There is an attractive force between them. If not that the nucleus is shielding the proton, this electron will have fallen inside the nucleus of the atom. So there is an attraction between them, because while electron is negatively charged, while proton is positively charged, automatically mean they will attract each other, because unlike charges attract while like charges repel. So in that case, the electron is being held by a proton. And don't also forget that the force holding proton to proton together, apart from the electrostatic force I have talked about, that is holding proton to proton together, or proton to neutrons together in a nucleus, is what we call strong nuclear forces. Now, and it enables the nucleus not to decay, not to be splitted. Normally, if these things are repelling each other, it can cause the nucleus to separate. That because if these forces, the proton and proton are under the influence of a repulsive force, what do you expect? They will want to separate, go in their various ways, and in doing that, they will now want to affect the shielding nucleus to break it up. But there is a force that is higher. There is a force that is greater than this particular electrostatic repulsive force, which is what we call the nuclear strong force. Nuclear strong force. So this nuclear strong force is the force that exists between proton and neutron, or proton and proton, or neutron and neutron, to hold the nucleus together. That means to make sure that the bond, and this force is higher. It overcomes the repulsive force created by the proton and proton. So that means that it now makes this atom to remain stable. So the stability of an atom is as a result of the strong nuclear force is greater or overcome the repulsive force that is created by the protons in the nucleus of an atom. Now, what makes electron to be held in their shell? We can say one of the things that can be responsible for that is because the electron is attracted to the proton inside the nucleus. So as such, now is being protected by what we call an electrostatic force of of attraction. So now we have talked about the structure of an atom, and I have told you that what that the force that is holding what proton to proton together is what we call what electrostatic force. Don't forget, while the neutron to proton to electron is what we call electrostatic force of what attraction, proton to proton repulsion. Now they want to break the bond, the nucleus into what separate the nucleus, but because there is a strong what nuclear force, a strong nuclear force that overcome the what the positive force created by the two by the protons to now keep the what the atom stable. Because for an atom to undergo decay, radioactive decay, it occurs in the nucleus. Radioactive decay does not occur at the outermost shell. It actually occurs in the nucleus of the atom. So now we have talked about the what, but there is something that you must know that I want to tell you. Now we talk about the chargeless what particle with mass. There is what we call a chargeless and massless particle. Let me just list only two here. We have what chargeless and what massless what particle. E.g. of that we have what they call the antineutrino. Antineutrino and neutrino. Antineutrino is what is gotten from the reaction. You can get antineutrino when you what decay a neutron. For example, this is a neutron. It will split into what a beta particle plus proton, then to produce what we call a antineutrino. This is a reaction of what how what antineutrino is what also produced. Don't forget, that means that we have some chargeless and massless particles. We also have some charge that what exists in a fractional form. We call them what quarks. Quarks. Quarks are what are charges that what that exist in fractional form. They are what they are in fraction. They are in fraction. We have two type of them. We have the what the up quarks, and we have what they call the down quarks. Down quarks. Now these quarks we are talking about now, the up quarks and down quarks, we now what have what they call the positive up quarks and the negative what up quarks. This one we have what positive up quarks, and we have what the what negative what up quarks. So also we have for the what down quarks, we have what they call positive what down quarks, and we have what they call what and we have what they call what negative what down quarks. So that means that the up quarks normally is what 2/3 electron, while down quarks is what 1/3 of electron. 1/3 of electron. We have the up quarks, we have the down quarks. So this one now, most of the times they always exist in pairs. So we always have write them like 2/3 plus or minus 2/3, while we write this one as plus or minus 1/3. Although we are still going to talk more in our next class. Now this one now is what is positive, that means plus 2/3a, while this one is what minus 2/3a. Then this one is what plus 1/3e, this one is minus 1/3e. So now these are what different type of quarks that we have what talked about. We have up quarks and down quarks. We have also talked about what we have looked at other things that surround what quarks, that they exist in pairs, and they also exist in fractions. They are charges, there's fractions of electrons. Also we have looked at everything. I've talked about all the things I needed to talk about in this part one of this video. This part one of introduction to what? To electrostatics. I believe that in our next class, we are going to talk more. We'll kick off from this quark aspect of it, and we'll also look at how charges, what are the principles that guides what charges? What are the principles that guides a charge? When we talk about charges, there are some principles that guides them that can be explained, that can be used to explain charges. And all this we are going to look at in the next class of this particular series of introduction to what? To electrostatics, which is going to be part 2. Please just stay tuned and subscribe. Click the notification button to always get notified. And those of you returning viewers, thank you for watching, for using your data. God bless you. Thank you. We appreciate that. And right now, I'll be leaving the studio. Thank you very much. God bless you.